People have seen distributive property before? Awesome. So do I need to go through the first couple here? We could if I wanted to.
Oh,
So we'll distribute out, multiply to everything inside.
Whoa.
Stop right there.
Whoa.
3x plus 18. Or you could distribute. You don't have to be on the left to distribute. You can multiply inside of parentheses, but it's multiply on the outside. What's n times n?
N.
One
N.
N.
One. N. 5, 6,
1.
7. A 0.
Oh, I heard it.
Oh, N squared. That's it, right? Squared. No.
N times n. How would we write that as an exponent?
Oh.
There's 2 of them. N squared plus 5n. All right, distributive property, we can also get a little more complex. We throw some negative signs in. If you want to distribute, say, -4 into this, then we'd have what? -4 times y is, what is it, -4y? What's -4 times -2?
Positive 8.
Oh, how do I know that was -2?
Because you add the opposite. Oh, yeah.
You could do plus a negative in there if you wanted. And -4 times -2 is positive 8. You could have left the subtraction and do -4 times 2 and do minus a negative. What's minus a negative? Positive as well. Whatever you're more comfortable with. What if they got just this negative sign floating around? How do we deal with that?
Well, that means like pretty much -1.
It does mean, oh man, that was first try. It took a little while to get that last time. I would change the negative sign to -1. What happens when you multiply something by 1?
It's itself.
It's just itself, doesn't change. So if we multiply by -1, now we can multiply by a number that won't change the value. But what will it do? Well, what if it's already negative?
Makes it positive.
So how about we, instead of using make it negative, what's maybe a better way to describe that? Make it the opposite of what it was, or change the sign, flip the sign. So if you distribute this -1, you get what? -3y plus 9? What if you have a fraction here? Holy cow. The rules don't change. And do not change this to 0.5. Please do not change this to 0.5. Okay? One of my goals for all of you is by the time you leave here, you're either A, not going to be scared of fractions anymore, or at minimum be able to use them effectively by the time you leave here. Okay? We're not avoiding fractions in here, and we're not going to be frightened of them by the time you leave here. Okay? Right now, since we're multiplying, this is just a number, so with the distributive property, you could just multiply them to each of them. Let's just distribute them out, and you get something like, say, 2n times 1/2 minus 6 times 1/2. But now you got to figure out how to multiply those two things together. How do you multiply a non-fraction or a whole number to a fraction? Okay, if you don't have a calculator, what happens? How do you do it?
Well, since it's half, I normally split them in half.
Okay, so since you know this, in this instance, it's half. So we could just find half of each of these numbers.
So 3.
So you can say n and
1.
minus 3. How about even more? In general, how do you multiply a fraction to a whole number? You put the whole number over 1, and then multiply straight across. So a great strategy we're going to use over and over again today is we'll put this whole number over 1 and multiply straight across. So you end up with, what's 2n times 1?
2n.
And what's 1 times 2?
2.
Okay. What's 6 times 1?
6.
And 1 times 2 is 2.
Very good.
Okay. So now, now that we've got them as combined as one fraction, let's reduce them. How many times does 2 go into 2? How many times does 2 go into 2? Not 6 times. 2 goes into 2.
One.
That was a lot harder than it should have been.
It's actually really fun.
Killing me. 2 goes into 2 once. How many times does 2 go into 6? 3. Okay. I'll erase this so we can see the problem above. Okay. What are the terms? What are the groups of numbers multiplied together and they're separated by adding or subtracting if you want? What are the individual groups here? Okay, 5 is one of them. How about negative 2x is another one? 6x is another one. And subtraction will change to plus and negative. It's 6x. That's negative 8. The terms are the individual groups. I changed any subtractions to plus and negative. And the terms are anything that's separated by an adding symbol.
Anything that's separated by what?
Anything separated by addition, by adding. Okay? So any group that's just multiplied together and separated by addition is called a term. Okay? Like terms are terms that have the exact same variable with the exact same exponents attached to those variables. They're identical as far as the variables are concerned. So what are some like terms here?
Negative 2x.
And the symbol for and. Negative 2x and 6x would be a group of like terms. Are there any other like terms?
No.
Negative 8.
Negative 8 and 5. This is the symbol for and. Some people have questions about it. The little 3 with the line through it. And
Really?
backwards 3.
I use it.
Or if you do like an ampersand, or you can do just the word and. Whatever. Okay, so the like terms have the exact same variables with the exact same exponents. Okay, in this case, negative 2x and 6x. Or if there's no variables, then they're like terms automatically. Okay. These two words are similar. These two terms are similar but different, and a very important difference. Okay, a coefficient. A coefficient is a number that is multiplied to a variable. A number, whether it's a fraction, a decimal, a whole number, that's multiplied to one of our variables. Okay? So in this case, one of the coefficients of this expression is negative 2. Is one of the coefficients. Okay? What would be the other coefficient in this expression? 6 is the other coefficient. Notice the coefficients don't have any of the variables. We're not going to write variables with coefficients. The coefficients are just the numbers multiplied. Constant is the opposite of a variable. Variable varies, can change. Constants don't change. Constants don't have variables attached to them. Constant terms are any terms that have no variables attached to them. So what would be, say, a constant term in this expression? What's one of them? 5 is one of the constant terms in this expression. What would be our other constant term? Negative 8 is our other constant term in this expression. Okay. Similar things, similar ideas, they're just numbers, but we got to know what the difference between them is. The difference is coefficients are multiplied to a variable as well. Okay. If I ask you to write an equivalent expression, that means use distributive property to simplify this and combine any like terms. I chose this example very deliberately because notice that I'm subtracting in between here. Okay? If you are subtracting outside of a group of parentheses, if there's subtraction and there is distributive property in particular, I can't stress enough that you need to start by writing this as plus negative of whatever is there. And you should have gotten 6x plus 18. And if you distribute -2 like I told you to, and you didn't try to cheat here, you get minus 16 minus 2x, or plus -16 plus -2x. And then when we finish this by combining like terms, the terms that are alike are what? 6x and -2x? What do those add up to? 4x. And what do, so we got those taken care of. And what do 18 plus -16 add to?
Whoa, what did you just do? What just happened?
Add up to 2.
You didn't tell me anything.
You distribute these first, and then I crossed them out so I didn't try to add them a second time.
Yeah, you
We distribute it here.
Yeah.
What's -2 times 8? -2 times x. Okay, what's, why did I crossed them out to stay organized? Something you already know how to do. Okay? First of all, inverse. Inverse in math means opposite. Undo. In particular, undo. So we're going to undo what? Multiply. What's another thing that undoes multiplying? Division. So we're going to figure out a way to rewrite a division problem into a multiply problem that'll help us undo. A multiplicative inverse, I told you already know how to do this. Another word for this is called a...
reciprocal.
It's called a reciprocal. Do we remember what a reciprocal is?
Yes. The opposite.
Not opposite.
Where you flip the fraction.
Yeah. Awesome.
No,
Flip the second guy.
Am I right?
Flip the second guy multiply.
Flip the... Oh, that's a good one. Flip the second guy and multiply. That rhymes. Pretty good.
You never heard that?
I've never done that before. Sweet.
What? You never
Way to go.
heard that?
Never done the rhyme before. Sweet. So this should go hopefully equally as quickly. But you're not allowed to write your answer as a decimal, so
What?
yeah, you have to leave it as a fraction. Wah, wah.
We don't have to divide it.
So you're going to need to figure out how to multiply. Change it, divide to a multiply. First of all, let's quickly find some multiplicative inverses.
7.
1/7 should be 7 over 1, which is 7. -2/5.
5 over -2.
5 over -2 or -5 over +2. Notice that this minus sign was right in between the fraction. Means you can either give it to the -2, give it to the 2, or give it to the 5. Don't give it to both. Give it to one or the other when you flip. You can put the minus on top, you can put the minus on the bottom, don't care, does not matter. But you can only have one of them.
Right? Because if just both, then it's positive.
Because if it's both, then it's positive. Yep, if it's supposed to be negative. Okay. What's the reciprocal of a whole number?
1/10.
Let's put the whole number over 1 and then flip it. So 1/2.
Never heard that.
Flip the second guy and multiply.
That's okay. Never heard that. Yeah.
How did you
Flip the
not
second
heard
guy and then multiply.
You get out.
Sure. That's good.
That was so funny.
18 times 1 over -3. Oh yeah, you're gonna need to simplify this thing. Well, how do I multiply 18 by this fraction? Oh, we did it on the front side. Let's turn the whole numbers into fractions, and then multiply straight across. What's 18 times 1?
Wait,
18.
why is it 1/3? Yeah, why don't you just make it?
Because if we're gonna, when you divide,
Oh, right.
you flip the second guy and multiply. You just told me this. Flip the second guy and multiply.
Wait, but why do you didn't explain it?
For whole numbers, it's not that big a deal, especially whole numbers to go into each other. It's going to give us a whole number answer. You don't really need to do this. But when you get to problems where now you got some fractions thrown in, well, now the flip the second one actually works pretty well. So we can change this into 16 times flip and multiply. Oh goodness. Now we got to reduce this. Sarah? Okay, so now I'm going to multiply these together. How do you multiply this? How about we
Over 1 and
put it over 1, and now we can multiply across and simplify. So you could say, one thing you could do is say 16 times negative 3 is negative 48. Negative 48 divided by 8 is negative 6. How about, rather than getting big numbers and reducing, let's try to reduce this while the numbers are small. How do we, are there any numbers on either the top side of the fractions or the bottom sides? Are there any numbers on opposite sides of fraction bars that could go into each other?
6 and 18.
6 and 18.
Or
Okay.
16.
Sorry, 16 and 8. A little bit. 16 and 8. So let's see. Does 16 go into 8?
2 times.
Yes.
No, 8 goes into
8 goes to 16, right? How many times does 8 go into 16?
Twice.
How many times does 8 go into itself?
0.
Once.
Once. Totally can.
Once. What's now 2 times negative 3?
6.
What's 1 times 1?
1.
Wait, but did you have to?
Negative 6 and 1.
Did you just simplify it after? Yeah.
Hey, nothing has changed. Flip the second guy and multiply. So this is what? Negative 3/8 times 10 thirds. So you could reduce negative 30 over 24. Or, let's try my way. Is there anything that goes into each other on top and bottom before we multiply?
Yeah. 3 and negative.
3 and negative 3 probably work together as a pair.
Yeah.
How many times does 3 go into 3?
One.
How many times does 3 go into negative 3?
Negative.
Negative once. That doesn't make sense, but negative once.
That's in my head.
How many times does... 8 doesn't go into 10 by itself, but I think there's a number that goes into each of those.
2.
2. Okay, how many times does 2 go into 8?
4.
How many times does 2 go into 10? Okay, now let's multiply what's left over. What's negative 1 times 5? And what's 4 times 1?
4.
That seems a lot easier to me than reducing negative 30 over 24. Okay. How do you simplify terms with multiple terms in the numerator but just one in the denominator? Well, the strategy here is that we can rewrite this as 2 separate fractions. You can rewrite this as 40x over 8 plus 32 over that same denominator. Kind of cool.
Magical.
Right? Because if we add fractions, you have to have a common denominator anyways. You can't add like 3/4 and 1/2 until you get them to have the same bottoms.
So it's 9x.
So let's see if we can't just separate these, and let's go the other direction. Let's separate these into 2 fractions that have the same bottom, and now reduce each of these individually. So how many times does 8 go into 40?
Just about
5.
5 times. And how many times
4
does 8 go into 32? 4 times?
9x.
Star. Oh yeah, what were those little?
No. Okay. We'll do this. This is our last one. 2x minus 8 over negative 4. Let's rewrite this as 2x over negative 4. How about we change this to plus negative 8? Make life a little bit better. Plus negative 8 over negative 4. And now reduce those individually. What's 2x over negative 4 reduced to?
Negative 2.
Not negative 2.
Positive 2.
Not positive 2.
Some sort of 2.
2's involved.
22.
2 and 4. How many times does 2 go into 4? Twice. So 1 and a 2 on bottom. So negative 1/2 of x.
Wait, why isn't it?
Can I get my notes?